Okay, so question 18 says that our horizontal rifle is fired at a bullseye. The muzzle speed of the bullet is 670 meters per second. The gun is pointed directly at the center of the bullseye, but the bullet strikes the target 0.025 meters below the center. What is the horizontal distance between the end of the rifle and the bullseye? So we start out by drawing our diagram, and we know that the bullet strikes 0.025 meters below the center. So for our x components, we know that the initial velocity in the x is 670 meters per second. This is because we know that the bullet is fired horizontally, therefore it has a horizontal x component of 670 meters per second. We know that the final velocity is the same, and that the acceleration in the x is 0 meters per second. We don't know our displacement. For our y components, we know that the initial velocity in the y is 0 meters per second because the bullet is fired horizontally, and this is a clip-style problem, so that's one of the properties of a clip-style problem. We don't know our final velocity. We know our acceleration is negative 9.81, and we know that displacement is 0.025 meters. And we don't know the time for either our x or our y components. So in order to solve this, we have to solve for the final velocity of the y first. So we find that using the equation that our final velocity squared equals to our initial velocity squared plus 2 times our acceleration times our displacement, that our final velocity is negative 0.7 meters per second. Then we find that in order to solve for our time, we use the equation that our final velocity in the y equals to our initial velocity in the y plus our acceleration times our time to give us a time of 0.07 seconds. Therefore, using the time that we found using the y components, we can plug in that time into our x component equation, which our displacement is equal to our final velocity in the x times our time minus our 1/2 of our acceleration times our time squared, to give us that the displacement in the x is equal to 46.9 meters.